Section 1700 Structural Concrete. Description: the works shall consist of producing, transporting, placing and compacting of structural concrete, including fixing, formwork and temporary works etc. Incidental construction accordance with these specifications and in conformity with the line grades and dimensions as shown on the drawing or as directed by the engineer. Materials: all materials shall conform to section 1000 of this specification. Grades of concrete: the grades of concrete shall be designated by the characteristic strength as given in table 1700-1, where the characteristic strength is defined as the strength of concrete below which not more than 5% of the test results are expected to fall. Grade of concrete: nominal mix concrete M15 M20, standard concrete M15 20 25 M30 40 45 50, high performance concrete M30 35 40 45 50 55 60 65 70 75 80 85 90. Characteristic strength in MPa 15 20 25 30 35 40 45 50 55 60 65 70 75 80 85 90. Normal mixed concrete is made on the basis of nominal proportioned by weight of its main ingredients: cement, coarse and fine aggregate and water. Standard concrete is made on the basis of design mix proportioned by weight of its ingredients, which in addition to cement, aggregates and water may contain chemical admixture to achieve certain targets. Values of various properties in fresh condition, achievements of which is monitored and controlled during production by suitable tests. Generally, concrete of grade up to M50 are included in this type. High performance concrete is similar to standard concrete but contain additional one or more mineral admixture providing binding characteristics and partly acting as inert filler material, which increases its strength, reduces its porosity and modifies its other properties in fresh as well as hardened condition. Concrete of grade up to M90 are included in this type. For concrete of grade higher than M90, the design parameter may be obtained from specialized literature and experimental results. The minimum grades of concrete and corresponding minimum cement content and maximum water cement ratio for different exposure conditions shall be as indicated in table 1700-2. For concrete subjected to sulfate attack, the minimum grades of concrete, minimum cement content and maximum water cement ratio and type of cement for different concentration of sulfate content shall be indicated in table 1700-3. Requirement of concrete for different exposure conditions using 20 mm aggregate exposure condition, moderate Severe, very severe. Maximum water cement ratio 0.45, 0.45 and zero point 0.4. Minimum cement content kg per mq 340, 360, 380. Minimum grade of concrete M25, M30, M40. On all three provisions given in above table for a particular exposure condition shall be satisfied. The term cement for maximum water cement ratio and minimum cement content shown in table included all cementitious material mentioned in clause 1715.2. The maximum limit of fly ash and ground granulated blast furnace slag in the blended cement shall be as specified in IS 1489 Part 1 and IS 455 respectively for plain cement concrete with or without surface reinforcement. The minimum grade of concrete can be lowered by 5 MPa and maximum water cement ratio exceeded by 0.05. Cement content shown in the above table shall be increased by 40 kg per mq for use of 12.5 mm nominal size aggregates and decreased by 30 kg per mq for use of 40 mm nominal size aggregate. If the requirement of maximum water cement ratio, minimum grade of concrete and minimum cement content more other durability consideration as given in 1702 are more restricted than those given in the table. The former will govern. Concentration of sulfate as a specific type of cement. Note 2. Minimum cement content, maximum water cement ratio, minimum grade of concrete. OPC, ordinary Portland cement. PPC, Portland pozzolano cement. PSC, Portland slag cement. SRPC, sulfate resisting Portland cement. The minimum cement content shall be as low as possible but not less than the quantities specified in table 1700-2 and 1700-3. The maximum cement content including any mineral admixture Portland cement component alone shall not exceed 450 kg per mq. Concrete used in any component or structure shall be specified by designation along with prescribed method of design mix or nominal mix for all items of concrete. Only design mix shall be used except where nominal mix concrete is permitted as per drawing or by the engineer. Nominal mix may be permitted only for minor bridges and culverts or other incidental construction where strength requirements are up to M20 only. Nominal mix may also be permitted for non-structural concrete or for street below open foundation. If the contractor so proposes, the engineer may permit the use of concrete of higher grade than specified on the drawing provided the higher grade concrete meet the specification applicable. The additional cost of such higher grade concrete shall be borne by the contractor. Proportioning of concrete prior to the start of construction, that is construction contractor shall design the mix. In case of design mix concrete or propose nominal mix in case of nominal mix concrete and submit to the engineer for approval. The proportions of material including admixture to be used: water reducing admixture including plasticizer or super plasticizer may be used at the contractor's option, subject to the approval of the engineer. Requirements of consistency: the mix shall have the consistency which will allow proper placement and compaction in the required position. Every attempt shall be made to obtain uniform consistency. Slump test shall be used to measure consistency of the concrete. The optimum consistency for various types of structures shall be as indicated in table 1700-4 or as directed by the engineer. The slump of concrete shall be checked as per IS 516. Requirement of consistency: type and slump at the time of placing of concrete. A structure with exposed inclined surface requiring low slump concrete to allow proper compaction. 25. Plain cement concrete. 25. RCC. A structure with widely spaced reinforcement, example solid columns, piers, abutment, footing, well 40 to 50. RCC, a structure with fair cognizance of reinforcement, example pier and abutment, caps, box culvert, well cap, wall with thickness greater than 300 mm, 50 to 75. RCC and PSC, structure with highly congested reinforcements, example deck slab, girders, box girders, wall with thickness less than 300 mm, 75 to 125. Underwater concreting through termi, example bottom plug, cast in situ piling, 150 to 200. Notwithstanding the optimum consistency indicated against serial number 1, 2, 3, the situation should be properly assessed to arrive at the desired workability with the adjustment of admixture. In each case where the concrete is to be transported through transient mixture and placed using concrete pump, under these circumstances the optimum consistency during placement of the work serial number 1, 2, 3 can be considered ranging from 75 to 150 mm. This is, however, subject to satisfying the other essential criteria of strength, durability, etc. and approval of the engineer. Requirements for design mix: target mean strength. The target mean strength of a specimen shall exceed the specified characteristics compressive strength by at least the current margin. The current margin for a concrete mix shall be determined by the contractor and shall be taken as 1.64 times the standard deviation of the sample test result taken from at least 40 separate batches of concrete of nominal similar proportions produced at site by the same plant under similar supervision over a period exceeding 5 days but not exceeding 6 months. Where there is insufficient data to satisfy the above, the current margin for the initial design mix shall be taken as given in table 1700-5. Current margin for initial design mix. Concrete grade M15 10, target mean is 1025. M20 10, target mean 30. M25 11, target win 36. M30 12, target win 42. M35 12, target win 47. M40 12, target win 52. M45 13, target win 58. M50 13, target win 63. M55, target win 14, 69. M60 14, 70, 16 for 74. M65 15, 80. M70 15, 85. 75 15, 90. 80 15, 95. 85 16, 101. M90 16, 106. The initial current margin given in table 1700-5 shall be used till sufficient data is available to determine the current margin as per sub-clause 1704. Trial mixes. The contractor shall give notice to the engineer to enable him to be present at the time of carrying out trial mixes. The preliminary testing of the cubes prior to commencement of trial mix design. All material forming constituents of proposed mix should have been tested and approval obtained in writing from the engineer based on test results of material. Draft mix design calculation for all grade of concrete to be used in the work shall be prepared after taking into account the provisions in the contract technical specifications. Guidelines of IS 10262, IS SP 23 and IRC 112 and is submitted to the engineer for approval prior to commencement of concreting. Trial mix design shall be performed for all grades of concrete, and trial mix which has been found successful shall be submitted by the contractor and approval obtained during concreting with the approved trial mix design. If a source of any constituents is changed, the mix design shall be revised and tested for satisfying the strength requirement. The initial trial mix shall be carried out in a laboratory approved by the engineer. However, engineer may permit the initial trial mixes to be prepared at the site laboratory of the contractor if a full-fledged concrete laboratory has been established well before the start of construction. To this entire satisfaction, sampling and testing procedures shall be in accordance with these specifications. When the site laboratory is utilized for preparing initial mix design, the production plant and means of transport employed to make the trial mixes shall be similar to those proposed to the use in the works. For each trial mix, a set of 6 cubes shall be made from each of 3 consecutive batches for purpose of testing. 3 cubes from each set of 6 shall be tested at an age of 28 days, and they are at an earlier age approved by the engineer. The cube shall be made, cured, stored, transported, and tested in accordance with these specifications. The mean strength of the 9 cube at 28 days shall exceed the specified characteristic strength by the current margin minus 3.5 MPa. Controlled strength of design mixes. Adjustment to the mix proportion. Adjustment to the mix proportion arrived at the trial mixes shall be made subject to the engineer's approval. In order to minimize the variability of strength and to maintain the target mean strength, such adjustment shall not be taken to imply any change in the current margin. Change of current margin when required by the engineer. Contractor shall recalculate the current margin in accordance with clause 1704-2-1. The recalculated value shall be adopted as directed by the engineer, and it shall become the current margin for concrete produced thereafter. Additional trial mixes. In case any changes are observed in the properties of fresh concrete and or strength or hardened concrete on the basis of early age tests, additional mix and test shall be carried out during production so as to control and bring the quality of concrete within acceptable limits. In case of any change in the source or properties of material, the design of mix shall be established. If requirements of nominal mixed concrete, requirements for nominal mixed concrete under otherwise specified shall be as given in table 1700-6. Requirements for nominal mixed concrete. M15 total quantity of dry aggregate by mass per 50 kg of cement to be taken as the sum of individual masses, fine and coarse aggregate kg. 350 proportion of fine to coarse aggregate by mass. Generally 1:2 subject to upper limit 1:1.5 and lower limit 1:2.5. Maximum quantity of water for 50 kg of cement liters. PCC 25, RCC dash. M20 to 50 and 25 and 22. Additional requirement. Concrete shall meet any different requirement as specified by the drawing or as directed by the engineer. The overall limits of deleterious substances in accordance with shall in concrete shall be as follows. total acid soluble chloride content in the concrete mix expressed as chloride ions shall not exceed the following value by mass of cement pre-stressed concrete 0.1% reinforced concrete in are very severe or extreme exposure condition 0.2% reinforced concrete in moderate exposure 0.3%. The total water soluble sulfate content of the concrete mix expressed as SO3 shall not exceed 4% by mass of cement in the mix. For concrete made with Portland pozzolana cement, Portland blast fumes, slag cement or mineral admixture, the setting time and rate of gain of strength are different from those for concrete made with OPC alone. Such modified properties shall be taken into account while deciding the desetting time, curing period, early age, loading and time of pre-stressing. Additional cube samples may be required to be taken for verifying the concrete properties, suitability of proposed mix proportion. The contractor shall submit the following information for the engineer approval: nature and source of each material, quantities of each material per cubic meter of fully compacted concrete. Either of the following appropriate existing data as evidence of satisfactory previous performance for the target mean strength, current margin, consistency and water cement ratio, and may any other additional requirements as specified. Full detail of test of trial mixes. Statement giving the proposed mix proportions for nominal mix concrete. Any change in the source of material or in the mix proportions shall be subject to the engineer's approval, prior approval. Checking of mix proportion and water cement ratio. In proportioning concrete, the quantity of both cement and aggregate shall be determined by weight, where the weight of cement per bag as given by the manufacturer is accepted. A reasonable number of bags shall be weighed separately to check the net weight, where cement is weighed from bulk stock at site and not by bag. It shall be weighed separately from the aggregate waters and shall either be measured by volume in calibration tanks or weighed. All measuring equipment shall be maintained in a clean and serviceable condition. Their accuracy shall be periodically checked. The specified water cement ratio shall always be kept constant and at its correct value. To this in moisture content in both fine and coarse aggregate shall be determined as frequently as possible. The frequency for a given job being determined by the engineer according to the weather condition. The amount of water to be added shall then be adjusted to compensate for variations in the moisture content. For the determination of moisture content in the aggregate, IS-2386 Part 3 shall be referred. Self-suitable adjustments shall also be made in the weight of aggregate to allow for their variation in weight due to variation in their moisture content. Grading of aggregate for pumped concrete. Material for pumped concrete shall be batched consistently and uniformly. Mixed size of aggregate shall not exceed 1/3 of the internal diameter of the pipe. The grading of aggregate shall be continuous and shall have sufficient ultra-fine material finer than 0.25 mm proportion of a fine aggregate passing through 0.25 mm shall be between 15 and 30%, and that passing through 0.125 mm sieve shall not be less than 5% of the total volume of aggregate. Admixture to increase workability can be added when pumping long distance and in hot weather. Set retarding admixture can be used. Fluid mixes can be pumped satisfactorily after adding plasticizer and superplasticizer. Suitability of concrete shall be verified by the mix and by performing pumping test. Admixture. Chemical admixture. Chemical admixtures such as superplasticizer or air entering, water reducing, accelerating and retarding agents for concrete may be used with the approval of the engineer, as the selection of an appropriate concrete admixture is an integral part of the mix design. The manufacturers shall recommend the use of any one of their products only after obtaining complete information of all the actual constituents of concrete as well as methodologies of manufacture, transportation and compaction and concrete proposed to be used in the work. Admixture additive conforming to IS 9103 may be used subject to approval of the engineer. However, the admixture additive generating hydrogen or nitrogen and containing chlorides, nitrates, sulfates or any other material likely to adversely affect the steel or concrete shall not be permitted. The general requirement for admixtures are given in Clause 1007 of this specification. Compatibility of the admixture with the cement and any other pozzolana or hydraulic adding shall be ensured by for avoiding the following problems. Requirements of large dose of superplasticizer for achieving the desired workability. Excessive retardation of setting. Excessive entertainment of large air bubbles and usually rapid stiffening of concrete, rapid loss of slump excessive segregation and bleeding. Mineral admixture. For use of mineral admixture refer 1714.1 to 1715.2. Size of force aggregate. The size maximum nominal of force aggregates for concrete to be used in various components shall be as given in table 1700-7. Maximum nominal size of force aggregate. RCC well curve 20, RCC PCC well steering 40, well cap or pile cap solid type pier and abutments 40. RCC work in girder slabs, bearing coat, curve, approach slab, hollow pier and abutment caps and piles 20. PSC work 20. Any other items as specified by the engineer. Maximum nominal size of aggregate shall also be restricted to the small of the following values: 10 mm less than the minimum lateral clear distance between individual reinforcements, 10 mm less than the minimum clear cover to the reinforcement, 1/4 of minimum thickness of member. The proportions of the various individual size of aggregates shall be so adjusted that the procedures, the density mix and the grading curve corresponds to the maximum nominal size adopted for the concrete mix. Equipment. Unless specified otherwise, equipment for production, transportation and compaction of concrete shall be as under. Production of concrete for overall bridge length of less than 200 meter, batch type concrete mixer, diesel electric operated with a minimum size of 200 liters, automatic water measuring system and integral wear, hydraulic pneumatic type. For overall bridge length of 200 meter or more, concrete batching and mixing plant fully automatic with minimum capacity of 50 m³ per hour. All measuring devices of the equipment shall be maintained in a clean and serviceable condition. Their accuracy shall be checked over the range in use when set up at each site and thereafter periodically as directed by the engineer. The accuracy of the measuring device shall fall within the following limits: measurements of cement plus minus 3% of the quantity of cement in each batch, measurement of water plus minus 3% of the quantity of water in each batch, measurement of aggregate plus minus 3% quantity of aggregate in each batch, measurement of admixture plus minus 3% of the quantity of admixture in each batch. Transportation of concrete dumpers, minimum 2 tons capacity, powered hoists, minimum 0.5 tons capacity, chutes, buckets, handled by cranes, transit truck mixer, concrete pump, concrete distribution booms, belt conveyors, cranes with skips, turnies. For compaction of concrete, internal vibrators, foam vibrators, screen vibrators. Internal vibrator size 25 mm to 70 mm. For foam vibrator, minimum 500 watts. Screen vibrator, full width of carriageway up two legs: batching, mixing, transporting, placing, and compaction. General: prior to the start of concreting, the contractor shall submit for approval of the engineer his program along with list of equipment proposed to be used by him for batching, mixing, transporting, and placing concrete. Batching of concrete. In batching concrete, the quantity of cement, aggregate, and mineral admixture, if used, shall be determined by mass. Chemical admixture, if solid, shall be determined by mass. Liquid admixture shall be measured in volume or mass, and water shall be weighed or measured by volume in calibrated tank. The concrete shall be sourced from one site or off-site batching and mix plants, or from approved ready mixed concrete plants preferred, having quality certification, except where quantity of properly graded aggregate of uniform quality can be maintained over a period of work. The grading of aggregate should be controlled by obtaining the coarse aggregate in different sizes and bleeding them in the right proportion when required. The different size being stocked in separate stockpiles. The material should be stockpiled several hours, preferably a day before use. The grading of coarse and the fine aggregate should be checked as frequently as possible to ensure that the specified grading is maintained. The water-cement ratio shall always be maintained constant at the correct value. To this in determination of moisture content in both fine and coarse aggregates shall be made as be adjusted to compensate for any observed variations in the moisture content, to allow for the various variations in mass of aggregate due to variation in moisture content. Suitable adjustment in the mass of aggregate shall also be made. Accurate control shall be kept on the quantity of mixing water, which when specified shall not be changed without approval. Grade mixing at site. All concrete shall be machine mixed in order to ensure uniformly and good quality of concrete. The ingredient shall be mixed in a power-driven batch mixer with hopper and suitable with batching arrangements, or in a central mix plant. Hand mixing shall not be permitted. The mixer or the plant shall be at an approved location, considering the properties of the mixes and the transportation arrangements available with the contractor. The mixer or the plant shall be approved by the engineer. Mixing shall be in continued till materials are uniformly distributed. A uniform color of the entire mass is obtained, and each individual particle of the coarse aggregate shows complete coating of mortar containing its a proportionate amount of cement. In no case shall mixing be done for less than 2 minutes. It shall be ensured that the mixers are not loaded above their rated capacities and are operated at a speed recommended by the manufacturer. When mineral admixtures are added at the mixing stage, their thorough and uniform blending with cement shall be ensured. If necessary, by longer mixing time, the addition of water and the completion of the initial mixing operation shall not be permitted. Mixers which have been out of use for more than 30 minutes shall be thoroughly cleaned before putting in a new batch, and also before changing from one type of cement to another. Ready mix concrete. Use of ready mix concrete proportion and mixed of the project site and delivered to site in a freshly mixed and unhardened state conditions to IS 4926, which shall be allowed with the approval of the engineer. Transport in concrete. Mixed concrete shall be transported from the place of mixing to the place of final deposit as rapidly as possible by methods which will prevent the segregation or loss of the ingredients. The method of transporting or placing of concrete shall be approved by the engineer. Concrete shall be transported and placed as near as practicable to its final position so that no contamination, segregation, or loss of its constituent materials take place. Concrete may be transported by transit mixer or properly designed buckets, or by pumping transit mixers or other hauling equipment when used through should be equipped with the means of discharge of concrete without segregation. During hot or cold weather, concrete shall be transported in deep containers. Other suitable methods to reduce the loss of water by evaporation in hot weather and heat loss in cold weather may also be adopted. When concrete is conveyed by chute, the plant shall be of such size and design as to ensure practically continuous flow. Slope of the chute shall be so adjusted that the concrete flows without excessive quantity of water and without any segregation of its ingredients. The delivery end of the chute shall be as close as possible to the point of deposit. The chute shall be thoroughly flushed with water before and after each working period, and the water used for this purpose shall be discharged outside the formwork. In case concrete is to be transported by pumping, the fresh concrete should have adequate fluidity and cohesion adhesiveness to be pumpable. Proper concrete mix proportioning and its trial should ensure this. The conduit shall be primed by pumping a batch of mortar through the line to lubricate it. Once the pumping is started, it shall not be interrupted, as concrete standing idle in the line is liable to cause plug. The operator shall ensure that some concrete is always there in the pump's receiving hopper. During operation, the line shall always be maintained clean and free of dents. Pipeline from the pump to the placing area shall be laid with minimum bends. For large quantity placement, a standby pump shall be available. Suitable air release valves, shut-off valves, etc. shall be provided as per site requirements. The pumping of priming mix, example, rich mix of creamy consistency to lubricate the concrete pump and pipeline shall precede the pumping of concrete. Continuous pumping shall be done to the extent possible. After concreting, the pipelines and accessories shall be cleaned immediately. The pipes for pumping shall not be made of material which has adverse effect on concrete. Aluminum alloy pipelines shall not be used. Placing of concrete, all formwork and reinforcement contained in it shall be cleaned and made free from standing water, dust, snow or ice immediately before placing concrete. No concrete shall be placed in any part of the structure until the approval of the engineer has been obtained. If concreting is not started within 24 hours of the approved being given, the approval shall have to be obtained again from the engineer. Concreting shall processed continuously over the area between the construction joints. Fresh concrete shall not be placed against concrete which has been in position for more than 30 minutes unless a proper construction joint is formed. The concrete shall be deposited as nearly as practicable in its original position. To avoid rehandling, method of placing should be such as to preclude segregation. Care should be taken to avoid displacement of reinforcement or movement of hormones. To achieve this, concrete should be lowered vertically in the form and horizontal movements of concrete inside this. The form should be as far as practicable be minimized. The concrete shall be placed and compacted before its initial setting so that it is amenable to compaction by vibration. The workability of concrete at the time of placement shall be adequate for the compaction equipment to be used. If there is considerable time gap between mixing and placing of concrete, as in the case of ready-mixed concrete plants or offshore batching and mixing plants. Concrete mix shall be designed to have approximately higher workability at the time of discharge from the mixer in order to compensate the loss of workability during transit. This is generally achieved by suitable chemical admixture. Keeping these considerations in view, the general requirement for each mixed concrete plant of site batching and mixing plants is that concrete shall be discharged from the truck mixer within 2 hours of the time of loading. A longer period may be permitted if suitable retarding admixtures are used. A valve forms drop chutes attached to hookers at the top should preferably be used to lower concrete to its bottom of the forms. As a general guideline, the permissible free fall of concrete may not exceed 1.5 meters and under no circumstances it be more than 2 meters. When the fall of larger height is involved, self-compacting concrete having adequate fluidity, cohesiveness and viscosity and uniform and completely fills every corner of the formwork by its own weight without segregation shall be used, except where otherwise agreed by the engineer. Concrete shall be deposited in horizontal layers to a compacted depth of not more than 450 mm when internal vibrators are used and not more than 300 mm in all other cases. Concrete, when deposited, shall have temperature of not less than 5 degrees Celsius and preferably not more than 30 degrees Celsius and in no case more than 40 degrees Celsius. In case of site mixing, fresh concrete shall be placed and compacted in its final deposition within 30 minutes of its discharge from the mixer. When the concrete is carried in properly designed ether operating continuously, the concrete shall be placed and compacted within 1 hour of the addition of cement and within 30 minutes of its discharge from the agitator. It may be necessary to add retarding admixture to concrete if trials show that the period indicated above the unacceptable. In all such matters, the engineer's decision shall be final. Compaction of concrete. Concrete shall be thoroughly compacted by vibration or other means during placing and work around the reinforcement tendons or duct formwork embedded mixture and into corners of the formwork to produce a dense homogeneous void free mass having the required surface finish. When vibrators are used, vibration shall be done continuously during the placing of each batch of concrete until the expulsion of air practically ceased and in a manner that does not promote segregation over vibration shall be avoided to minimize the risk of forming a weak surface layer when external vibrators are used. The design of homework and the position of vibrator shall be such as to ensure efficient compaction and to avoid surface blemishes. Vibrations shall not be applied through reinforcement, and where vibrators of immersion type are used, contact with reinforcement and all injured like duct etc. shall be avoided. When internal vibrators are used, they shall be inserted vertically to the full depth of the layer being placed and ordinarily shall penetrate the layer below for a few centimeters. The vibrator should be kept in place until air bubbles is escaping from the surface and is withdrawn slowly to ensure that no hole is left in the concrete. Care being taken to see that it remains in continued operations while being withdrawn. The internal vibrators shall be inserted in an orderly manner, and the distance between insertions should be about 1.5 times the radius of the area visibly affected by vibrations. Additional vibrators in serviceable condition shall be kept at site so that they can be used in event of breakdown. Mechanical vibrators used shall comply with IS 2502, IS 2506, IS 2514 and IS 4656. Construction joints. Construction joints shall be avoided as far as possible. In no cases shall the location of such joints be changed or increased from those shown on the drawing except with the express approval of the engineer. Joints should be positioned where they are readily accessible for preparation and concreting. Construction joints should be positioned to minimize the effect of the discontinuity of the durability, structural integrity and appearance of the structure. As far as possible, joints should be provided in no aggressive zones, but if joints in aggressive zones cannot be avoided, they should be sealed. Joints should be located away from the regions of maximum stress caused by loading, particularly where shear and bond stress are high. In beams and slabs, joints should not be near the supports. Construction joints between slabs and ribs in composite beams shall be avoided. For box girders, there shall be no construction joint between the soffit and waves. Joints should be either vertical or horizontal. For a vertical construction joint, the lifts of concrete shall finish level or at right angles to the axis of the member. Concrete shall be continued right up to the joint. Before resuming work at a construction joint, when concrete has not yet fully hardened, all latent shall be removed thoroughly. The surface shall be roughened, taking care to avoid dislodgement of coarse aggregate. Concrete shall be brushed with a stiff brush soon after casting. While the concrete has only slightly stiffened, if the concrete has partially hardened, it may be treated by wire brushing or with a high pressure water jet, followed by drying with an air jet. Immediately before the new concrete is placed, fully hardened concrete shall be treated with mechanical hand tools or grit blasting, taking care not to split or crack aggregate particles. The particle of first placing a layer of mortar or grout when concreting joints shall be avoided. The old surface shall be soaked with water without leaving bubbles immediately before starting concrete. The new concrete shall be thoroughly compacted against it. Where there is likely to be a delay before placing the next concrete lead to concreting underwater. When it is necessary to deposit concrete underwater, the method, equipment, materials, and proportions of mix to be used shall be got approved from the engineer before any work is started. Concrete shall not be placed in water having a temperature below 5 degrees Celsius. The temperature of the concrete when deposited shall not be less than 16 degrees Celsius, not more than 30 degrees Celsius. Copper dams or foams shall be sufficiently tight to ensure still water conditions if practicable, and in any case to reduce the flow of water to less than 3 meters per minute through the space into which concrete is to be deposited. Copper dams or foams in still water shall be sufficiently tight to prevent loss of motor through the joints in the walls. Pumping shall not be done while concrete is being placed or until 24 hours thereafter to minimize the formation of latent. Care shall be exercised not to disturb the concrete as far as possible while it is being deposited. All underwater concreting shall be carried out by trimming method only. The number and spacing of trimming should be worked out to ensure proper concreting. However, it is necessary to have a minimum number of two trimming for any concreting operation so that even if one of the terminal goes out of commission during concreting, the other can be used to complete the work. The concreting when started should continue without interruption for the full height of the member being completed. The capacity of the concrete production and placement equipment should be sufficient to enable the underwater concreting to be completed uninterrupted within the stipulated time. The top section of the tree shall have a hopper large enough to hold one full batch of the mix or the entire contents of the transporting bucket, as the case may be. Tree pipe shall not be less than 200 in diameter and shall be large enough to allow a free flow of concrete and strong enough to withstand the external pressure of the water in which it is suspended. Even if a partial vacuum develops inside the pipe, preferably flagged steel pipe of adequate strength shall be used. A separate lifting device shall be provided for each tree pipe with its hopper at the upper end, unless the lower end of the pipe is equipped with an approved automatic check valve. The upper end of the pipe shall be plugged with a warding or gunny sacking or other approved material before delivering the concrete to the dummy pipe through the hopper, so that when the concrete is forced down from the hopper to the pipe, it will force the plug and along with it any water in the pipe down the pipe and out of the bottom end, thus establishing a continuous stream of concrete. It will be necessary to raise the tree slowly in order to allow a uniform flow of concrete at all times. After placing of concrete is started and until all the required quantity has been placed, the lower end of the pipe shall be kept below the surface of the plastic concrete and shall not be taken out. Of concrete. This will cause the concrete to build up from below instead of flowing out over the surface, and thus avoid formation of layers of latex. It is advisable to use retardant or suitable superplasticizer to retard the setting time of concrete, which shall be established before the commencement of work. Concrete in extreme water. Concreting in cold weather, where concrete is to be deposited at or near freezing temperature. Precautions shall be taken to ensure that at the time of placing, it has a temperature of not less than 5 degrees Celsius and that the temperature shall be maintained above 4 degrees Celsius until the concrete has hardened. When necessary, concrete ingredients shall be heated before mixing, but cement shall not be heated artificially other than by the heat transmitted to it from other ingredients of the concrete. A stockpiled aggregate may be heated by the use of dry heat or steam. Aggregate shall not be heated directly by gas or on sheet metal over fire. In general, the temperature of aggregates or other shall not exceed 65 degrees Celsius. Salt or other chemicals shall not be used for the prevention of the freeze. No frozen material or materials containing ice shall be used. All concrete damaged by frost shall be removed. Concrete exposed to freeze weather shall have entirely air and the water content of the mix shall not exceed 30 liters per kg of cement. To counter slower setting of concrete, accelerators can be used with the approval of the engineer. However, accelerators containing chloride shall not be used. Concreting in hot weather. When depositing concrete in hot weather, precautions shall be taken so that the temperature of wet concrete does not exceed 30 degrees Celsius while placing. This shall be achieved by using chilled mixing water, using crushed ice as a part of mixing water, sanding stockpiles or of aggregates from dark rays of the sun, sprinkling the stock piles of coarse aggregates with water to keep them moist, limiting temperature of cement below 30 degrees Celsius at the time of use. Starting curing before concrete dries out, restricting time of concreting as far as possible to early morning and late evening. When ice is used to cool mixing water, it will be considered as a part of the water in design mix and under no circumstances shall the mixing operation is considered complete until all ice in the mixing drum has melted. The contractor will be required to state his methodology for the engineer's approval when temperature of concrete are likely to exceed 30 degrees Celsius during the work. Protection and curing. General. Concreting operations shall not commence until adequate arrangements of concrete curing have been made by the contractor. Curing and protection of concrete shall start immediately after contraction of the concrete. The concrete shall be protected from premature drying out, particularly by solar radiation and wind. High internal thermal gradients reaching out by rain and flowing water. Rapid cooling during the flow few days after placing. low temperature or frost vibration and impact which may disrupt the concrete and interfere with its bond to the reinforcement. Vibration caused by traffic including construction traffic. Concrete shall be protected without allowing egress of external water by means of wet, not dripping, gunny bags, hasten, etc. Once the concrete has attained some degree of hardening, approximate 12 hours after mixing, moist curing shall commence and be continued through the requisite period. Where members are of considerable size and length with high cement content, accelerated during method may be applied as approved by the engineer. Water curing. Water for curing shall be as specified in section 1000 of this specification. Sea water shall not be used for curing. Sea water shall not come into contact with concrete member before they have attained adequate strength. The concrete should be kept constantly wet by running or covering of sprinklers for porous pipe for a minimum period of 14 days after completing, except in the case of concrete with rapid hardening cement where it can be reduced to 5 days. Water should be applied on the surface after the final set. Curing through watering shall not be done on green concrete on formed surfaces. Curing shall start immediately after the forms are stripped. The concrete shall be kept constantly wet with a layer of sacking, canvas, resin, or similar absorbent material. Steam curing. When steam curing is adopted, it shall be ensured that it is done in suitable enclosure to contain the live steam in order to minimize moisture and heat. Those are the initial application of the steam shall be after about 4 hours of placement of concrete to allow the initial set of the concrete to take place. Where retarders are used, the waiting period before application of the steam shall be increased to about 6 hours. The steam shall be at 100% relative humidity to prevent loss of moisture and to produce excess moisture for proper hydration of the cement. The application of steam shall not be directly on the concrete. Steam curing is applied in closure or tunnels through which concrete members are transported on a conveying system. Alternately, portable enclosures or plastic covers are placed over precast members and steam is applied to the enclosures. The rate of increase or decrease of temperature should not be more than 10 degrees Celsius to 20 degrees Celsius per hour, and the maximum shall be about 70 degrees Celsius. The maximum temperature shall be maintained until the concrete has attained the desired strength required at the end of steam curing period, and small be decided by prior trials. When steam curing is discontinued, the air temperature shall not drop at a rate exceeding 10 degrees Celsius per hour until a temperature of about 10 degrees Celsius above the ambient temperature outside has been reached. Steam curing of concrete shall be followed by water curing for at least 7 days. The concrete shall not be exposed to temperature below freezing for at least 6 days after curing. Curing compound membrane forming curing compound consisting of waxes, resins, chlorinated rubber sheet may be permitted by the engineer in a special circumstances. Curing compound shall not be used for any surface which requires further finishing to be applied. All construction joints shall be moist cured, and no curing compound shall be permitted in location where concrete surfaces are required to be bonded together. Liquid membrane forming a compound shall conform to ASTM C309, and the curing efficiency shall be as per ASTM C156. Curing compound shall be continuously agitated during use. All concrete cured by this method shall receive two applications of the curing compound. The first coat shall be applied immediately after acceptance of the concrete finish. If the surface is dry, the concrete shall be saturated with water and curing compound applied as soon as the surface film of water disappears. The second application shall be made after the first application has set. Placement disappears. The second application shall be made after the first application has set. Placement in more than two coats may be required to prevent streaking. The membrane formed shall be stripped off after 14 days. When curing is complete, impermeable membranes such as sheet materials for curing concrete conforming to ASTM C171 or polyethylene sheeting covering closely the concrete surface may also be used to provide effective barriers against evaporation. Finishing. Immediately after the removal of forms, exposed bars or bolts, if any, shall be cut inside the concrete member to a depth of about 50 mm below the surface of the concrete, and the resulting holes filled with cement mortar. All pins housed by form joints, all cavities produced by the removal of form ties, and all other holes and depressions, honeycombs, spots, broken edges or corners, and other defects shall be thoroughly cleaned, saturated with water, and carefully pointed and adhered to with mortar. The mortar shall be of cement and fine aggregate, mixed in the proportion used in the grade of concrete that is being finished, and of as dry a consistency as possible. Considerable pressure shall be applied in filling and pointing to ensure thorough filling in all white surface which have been pointed shall be kept moist for a period of 24 hours. Special pre-packaged proprietary mortar shall be used where appropriate or where specified by the drawing. All construction and expansion joints in the completed work shall be left carefully rolled and free from any mortar and concrete. Expansion joint field shall be left exposed for its full length with clean and true edges. Immediately on removal of forms, the concrete work shall be examined by the engineer before any defects are made good. The work that has scatters or contains honeycombing to an extent detrimental to structural safety and architectural appearance of the member shall be rejected. Surface defects of a minor nature may be accepted. On acceptance of such work, the same shall be rectified by the engineer. Mortar. The mortar shall be of cement and fine aggregate mixed in proportions used in the grade of concrete that is being finished and of as dry a consistency as possible. Considerable pressure shall be applied in filling and pointing to ensure through filling in all white surface which have been pointed shall be kept moist. For special pre-packed and ordinary mortar shall be used where appropriate or other specified in the drawing. All construction and expansion joints in the completed work shall be left carefully tools and free from any mortar and concrete. Expansion joint field shall be left exposed for its full length with clean and true edges. Immediately on the removal of forms, the concrete work shall be examined by the engineer before any defects and made good. The work that has changed or contains honeycombing to an extent detrimental to structural safety or architectural appearance of the member shall be rejected. Surface defects of a minor nature may be accepted on acceptance of such work same shall be rectified as directed by the engineer. Concrete with blended cement or mineral admixture. Production of concrete. In order to improve the durability of the concrete, use of blended cement or blended of mineral admixture is permitted. The maximum limit of fly ash and ground granulated blast fume slag in concrete shall be as specified in clause 17.15.2. Bleeding at a site shall be permitted only through a specific facility with complete automated process control to achieve the specified design. quality through RMC plant with similar facility. Modified properties for concrete made with Portland pozzolana cement, Portland blast fillings, slag cement or mineral ready mixture. The setting time and rate of fill of strength are different from those of concrete made with OPC alone. Cognizance of such modified properties shall be taken in deciding the setting time, initial time or restriction, for early race loading. Compatibility of chemical admixtures, compatibility of chemical admixture and super plasticizer with Portland pozzolana cement, Portland blast furnace slag cement and mineral admixture shall be ensured by trials outlined in clause 1705. Additional test in addition to the strength test prescribed in other sections of the specification, the following additional tests are required to be carried out from consideration of durability. Rapid chloride ion permeability test. Rapid chloride ion permeability test on as per ASTM-C 1202 at 56 days for extreme, very severe and severe condition of exposure. The permissible value of chloride ion permeability for extreme condition 800 columns, very severe condition 1200 columns and severe exposure condition 1500 columns. Water permeability test. Water permeability test as per DIN 1048 part 5 1991 shall be carried out as described in clause 1717.2.5.5. High performance concrete. High performance concrete. High performance concrete shall be used where special performance requirements of high strength, high early strength, high workability, low permeability and low durability for severe service environments and required production and use of such concrete in the field shall be carried out with high degree of uniformity between batches and very stringent quality control. Materials: cement, mineral admixture, chemical admixture, aggregate and water shall conform to section 1000 of this specification, and this section fly ash when used shall neither be less than 20% nor shall be greater than 35% of the total by mass of ordinary Portland cement and fly ash and shall conform to grade 1 of IS 3812. Ground granulated blast furnace GGBS slag when used shall neither be less than 50% nor greater than 70% of total mass of the ordinary Portland cement and a GGBS and shall conform to IS 12089. Silica fume conforming to IS 15388 shall be used. The cement content of concrete, inclusive of any mineral admixture, shall not be less than 380 kg per m3. The cement content, excluding any mineral admixture, Portland cement content alone shall not exceed 450 kg per m3. The water cement plus all cementitious materials ratio should generally not exceed 0.33, but in no case shall be more than 0.4%. 0.4. Compactability of admixture. Compactability of the superplasticizer and admixture with the cement and any other pozzolanic or hydraulic dilutes shall be ensured by terms or outlined under clause 1705. Characteristic strength and target mean strength. Characteristic strength with the initial target mean strength of concrete shall be as given in table 1700-8. The target mean strength shall be calculated as per 1704-2 and obtain data on a standard deviation from sufficient sample. Grade. Specific characteristic: compressive strength at 28 days. Target mean strength MPa M40 40 52, M45 45 58, M50 50 63, 155 55 69, 1 M60 60 74, M65 65 80, M70 70 85, M75 75 90, 1 M80 80 95, M85 85 101, M90 90 106. Workability and other requirements. Workability: concrete mix design, field trial mixes, chloride and sulfate content shall be as laid down in other sections of this specification. Mixing of concrete: the concreting plants and means of transportation employed to make trial mixes and to transport them to representative distances shall be similar to the corresponding plant and transport to be used in the work. The optimum sequence of mixing of ingredients shall be established by trials. Mixing time may be longer than in normal grade concrete mixture. Normal grade concrete mixes: the temperature of concrete at the time of placement shall not exceed 25 degrees Celsius. The temperature of concrete at the mixing stage should be lower. The temperature of concrete at the time of placement shall not exceed 25 degrees Celsius. The temperature of concrete at the mixing stage should be lower to allow for raise in temperature during transport. When considerable distance of transport is involved, particular attention should be paid to ensure retention of slump as targeted for placement. For type tests, mock-up trials or type test may be carried out to ensure that the concrete can be satisfactorily placed and compacted, taking into account the location of placement and provision of reinforcement. Kept a required place adjustment made in concrete mix design and or detailing of reinforcement. Curing of concrete. High performance concrete containing silica fume is more cohesive than normal mixes, hence there is a little or no bleeding and no bleed water to raise to the surface to offset water loss due to evaporation. Plastic shrinkage cracking is possible. If curing is not proper, initial curing should commence soon after initial setting of concrete. Concrete should be covered with moist covers, opaque colored plastic sheets, or suitable curing compound. Final moist curing should commence after final setting of concrete and continue for at least 14 days. Additional test for concrete. Apart from the strength test described in other sections of this specification, the additional test as specified under clause 1714.3 shall also be carried out. Tolerances. The tolerances for dimension, shape, or various components shall be as indicated in the specifications or shown on the drawing or as directed by the engineer. Test and standards of acceptance concrete shall conform to the surface finish and tolerance as prescribed in these specifications for respective components. Random sampling and lots of by acceptance inspection shall be made for the 28 days and Q strength of concrete. Concrete under acceptance shall be notionally divided into lots for the purpose of sampling below before commencement of work. The basis of delimitation of lots shall be as follows. No individual lot shall be more than 30 m3 in volume. Different grades of mixes of concrete shall be divided into separate lots. Concrete of a lot shall be used in the same identifiable components of the bridge. Concrete of a lot shall be used in the same identifiable components of the bridge. Sampling and testing concrete for preparing three test cubes shall be taken from a batch of concrete at points of delivery for construction according to procedure laid down in IS 1199. A random sampling procedure shall be adopted which ensures that each of the concrete batches forming the lot under acceptance inspection has equal chance of being chosen for taking cubes. 150 cubes shall be made, cured and tested at the age of 28 days for compressive strength in accordance with IS 516. The 28 days test strength result for each cube shall form an item of the sample. Tests at other age shall also be performed if specified. When automated batching plant, ready mixed concrete plant is located away from the place of use and the time gap between production and placement is more than the initial setting time, or where any ingredients are added subsequent to mixing, separate sets of samples shall be collected and tested at batching plant and at location of placement. The results shall be compared and due to make suitable adjustment at batching plant so that properties of the concrete at placement are as per the requirements. Test specimen and sample strength. Three test specimens shall be made from each sample for testing at 28 days. Additional cube may be required for various purposes such as to determine the strength of concrete at 7 days or for any other purposes. The test strength of the sample shall be the average of the strength of 3 cubes. The individual variation should not be more than plus minus 15% of the average. If variation is more, the test result of the samples are invalid. Frequency. The minimum frequency of sampling of concrete at each grade shall be in accordance with table 1700-9. Minimum frequency of sampling. Quantity of concrete in work MQ. Number of samples 1 to 5. 1. 6 to 15 MQ. 2. 16 to 30 MQ. 3. 31 to 50 MQ. 4. 51 and above. 4 plus 1 additional sample for each additional 50 MQ or part thereof. At least one sample shall be taken from each shift of work acceptance criteria. Compressive strength Q. The concrete shall be taken as having the specified compressive strength when both the following conditions are met. The mean strength determined from any group of 4 consecutive Non-overlapping sample exceed the specified characteristic compressive strength by 3 MPa. Strength of any sample is not less than the specified characteristic compressive strength minus 3 MPa. The quantity of concrete represented by the test result include the batches from which the first and last sample were taken together with all intervening batches. Course. When the concrete does not satisfy both the conditions given in above, a representative course shall be extracted from the hardened concrete for compression test in accordance with the method described in IS 1199 and tested to establish whether the concrete satisfies the requirement of compressive strength. Evaluation of compressive strength by taking course may also be done in case of doubt regarding the grade of concrete underused, either due to poor workmanship or based on result of Q strength test. The location from which core samples are to be taken and their number shall be decided so as to representative of the whole of the concrete under consideration. However, in no case shall fewer than 3 cores be tested. Cores shall be prepared and tested as described in IS 516. Concrete in the member represented by a core test shall be considered acceptable if the average equivalent cube strength of the course is equal to at least 85% of the cube strength of the grade of concrete specified for the corresponding age, and no individual core has a strength less than 75% of the specified strength. Chloride and sulfate content. The total chloride and sulfuric anhydride SO3 content of all the constituents of concrete as a percentage of mass of cement in the mix shall not exceed the value given in this section. Density of fresh concrete, where minimum density of fresh concrete is specified, the mean of any 4 consecutive non-overlapping samples shall not be less than the specified value, and any individual sample results shall not be less than 97.5% of the specified value. Density of hardened concrete, where minimum density of hardened concrete is specified, the mean of any 4 consecutive non-overlapping samples shall not be less than the specified value, and any individual sample result shall not be less than 97.5% of the specified value. Permeability test, water permeability test as per DIN 1048 Part 5 1991 shall be carried out as described below. A cylindrical test 150 mm dia and 160 mm high shall be prepared after 28 days of curing. The test shall be conducted between 28 and 35 days. The test specimen shall be fitted in a machine such that a specimen can be subjected to a water pressure of up to 7 bar. A typical machine is shown in Appendix 1700 by 1. The concrete specimen shall be subjected to a water pressure of 0.5 meter per mm square from the top for a period of 3 days. The pressure shall be maintained constant throughout the test period. If the water penetrates through to the underside of the specimen, the test may be terminated and the specimen and rejected as failed. After 3 days, the pressure shall be released and the sample be taken out. The specimen shall be split in the middle by compression applied on 2 round bars on opposite side above and below. When the split face shows signs of drying after 5 to 10 minutes, the maximum depth of penetration in the direction of height shall be measured with the scale and extent of water penetration established. The mean of maximum depth of penetration obtained from 3 specimens thus tested shall be taken as the test result, and it shall not exceed 25 mm. If the concrete is not able to meet any of the standards of acceptance as prescribed, the effect of such deficiency on the structure shall be investigated by the contractor as it is directed by the engineer. The engineer may accept the concrete as substandard work. Any additional work required by the engineer for each acceptance shall be carried out by the contractor at his cost. In case the concrete is not found to be acceptable even after investigation, the contractor shall remove the reject concrete forthwith. When durability of concrete is desired, the rapid chloride ion permeability test as stated under clause 1714.3.1 shall also be performed in addition to above tests. Measurement for payment. Structural concrete shall be measured in cubic meter. In reinforced or pre-staged concrete, the volume occupied by reinforcement or pre-staging cable and sheathing shall not be deducted. The slab shall be measured as running continuous. The slab shall be measured as running continuously through and the as in the portion below the slab rate. The contract unit rate for structural concrete shall cover cost of all materials, labor, tools, plants and equipment required for mixing, transporting and placing of in position, vibrating and compacting, finishing and curing as per this section or as directed by the engineer, including all incidental expenses, sampling and testing, quality assurance and supervision, unless mentioned separately as an item in the contract unit rate for concrete shall also include the cost of providing fixing and removing formwork required for concrete work as per section 1500 of these specifications. If the concrete is found to be acceptable by the engineer as substandard work, the contractor shall be subjected to reduction in his contract unit rate for deficiency in compressive strength of concrete when accepted by the engineer. The reduction in rate shall be applied as under percentage of reduction in rate design strength minus observed strength by design strength into 100.